Hello, students. We're going to work on our final section of this engineering unit where we are calculating areas and volumes. And today we're going to look at volume that is calculated by summing up areas of cross sections that are familiar shapes like squares, rectangles, triangles, semicircles, and so on. And I wanted to do a little bit of an introduction to this lesson just to make sure you understand this is different from volumes that are done by rotation. When we look at rotation, we've got everything based on a cylinder where you have pi r squared h as the basis for your integration. These are going to be calculating volumes based on areas of shapes and accumulating those areas. So I wanted to show you a few pictures. This first one is a shape where the cross sections are rectangles. They're cut perpendicular to the x-axis. And if you would imagine multiple rectangles being stacked right up next to each other, that if you accumulated those areas, you would get the volume of the shape that's shown. And so likewise, I've got another picture where this time the shapes of the cross sections are squares. If you would imagine multiple squares stacked up close to each other so that the depth of those squares was infinitely small, then you would see that you would get the volume of the shape that's shown there. And I might add that those squares are cut perpendicular to the y-axis in that problem. And then your third picture, and this one might actually be the easiest one to see what's going on, is a shape where the cross sections are triangles. So again, you might be able to see the triangles a little bit better if you were to stack infinitely many triangles in that shape and calculate the area of each of those triangles, then you would get the volume of the shape. And that's exactly what integration does. So we're going to stick to familiar shapes. We're going to work with the square, the rectangle, the triangle, and the semicircle. You can use trapezoids, ellipses, and other shapes, but we're going to stick with these four. And as we are working on the integration, one of the things that you'll need to pay attention to is the cut. So if the cut is taken perpendicular to the x-axis, then your integration is based on x. So you would want your equations to be in terms of x, like y equals something x, and use dx. If your cuts are taken perpendicular to the y-axis, then the volume is based on y, and your limits of integration are based on y. You would solve your equations for x equals, and it would be in terms of a dy. So you will be working on volumes today with cross sections, and therefore we will not be necessarily using pi r squared h unless for some reason your problem involves a semicircle or a circle, in which case that area would involve at least the pi r squared. So we'll go on to the next video for your first example. All right, so for our first example of calculating volume by cross sections, I've chosen to work with a solid where the base of that solid is created by the lines y equals negative 1/4 x plus 1, x equals 0, and y equals 0. And so you see this base shown in the graph. And I want you to be sure you understand that that is the bottom of the shape that's generated. And then the cross sections are semicircles. So if you could visualize those semicircles as three-dimensional, that'll help you get a better idea of what the solid looks like. So we're calculating the volume using cross sections that are semicircles cut perpendicular to the x-axis. So we need to know a little bit about that semicircle. And the easiest thing to find out first is the diameter. And so that would be from the line down to the x-axis. And that is just the equation that we were given, negative 1/4 x plus 1. So the radius, which would be half of the diameter, I want to multiply 1/2 through there. And so I would get negative 1/8 x plus 1/2. And then I need the area of the semicircle because I'm going to be accumulating those areas. So that would be, of course, 1/2 pi r squared. And so for our problem, 1/2 pi times negative 1/8 x plus 1/2 squared. So now we'll move to the calculation of the volume of the solid that's generated. So we'll integrate, since it's cut perpendicular to the x-axis, we'll use our x values as our limits of integration. So from 0 to 4, and we're integrating whatever we got for our area equation. So 1/2 pi times negative 1/8 x plus 1/2 squared. All right, so that volume is going to equal 1/2 pi times the integral from 0 to 4. And then we will need to square the negative 1/8 x plus 1/2. So that's going to square and become 1/64 x squared minus, and then we'll have 1/16 and 1/16. That'll be negative 2/16, which reduces to negative 1/8 x plus 1/4. This is what we're integrating, dx. So now we'll actually do the integration. And so that's volume equals 1/2 pi. And then we'll have 1/64 x to the third over 3 minus 1/8 x squared over 2 plus 1/4 x. All of this is evaluated on 0 to 4. And again, with this lesson, I'm going to assume that you can plug in the 4 and the 0. You should end up with a final answer of 1/6 pi or pi over 6, however you want to think about it. Now, one thing that I want to see if I can get in before this video is up, we could ask you to do this same problem, but do a different cross section. So if I asked you to do cross sections that are squares, one nice thing is you already know an important piece of information because the length of the square of a side of a square would be the same as the diameter that I've got shown. And on a square, the area of a square is just that side times itself. All right, for our second example, we're going to look at a solid with a triangular base that has triangles as its cross sections. The triangles are equilateral cross sections, and they are perpendicular to the x-axis. So the first thing that we're going to have to figure out is the length of the base of the triangular cross sections. So we're figuring out this length, which is right here in our base. So that length is going to be the top line, which is 1 minus x over 2, minus the bottom line, which is -1 plus x over 2. And so if we simplify, we would get 1 minus x over 2 plus 1 minus x over 2, and that's going to simplify so that we get 2 minus x. So 2 minus x is the length of our base. Now the area of a triangle is 1/2 times the base, which we now have as 2 minus x, times the height. We're going to have to calculate the height by looking at this altitude of this triangle. We know since it's an equilateral triangle that each angle is 60 degrees. And so using that altitude, I've created a 30, 60, 90 right triangle. So the altitude is going to be a long leg when you look at that arrangement, and the long leg is equal to the short leg times the square root of 3. The short leg in our drawing is half of this base. So 1/2 times 2 minus x times the square root of 3 is going to be our long leg, which is the height of our triangle. So 1/2 times 2 minus x times the square root of 3. And we'll simplify that so that we have the area equaling square root 3 over 4 times 2 minus x squared. So now we're ready to do the calculus. We're doing the volume, and that's going to equal the integral. Remember, we're accumulating those equilateral triangle areas. So we want to move along the x-axis from 0 to 2. And our area is the square root of 3 over 4 times 2 minus x squared dx. So we'll bring out the square root 3 over 4, integrate from 0 to 2. We'll multiply this out, 4 minus 4x plus x squared dx, and then actually do the integration as our next step. So volume would equal the square root 3 over 4, and then evaluating will have 4, or integrating will have 4x minus 4x squared over 2. That'll give us 2x squared plus x to the third over 3. And this is evaluated from 0 to 2. Substituting in the 2 and the 0, you'll get the volume equaling 2 square root 3 over 3. All right, we're going to look at our last example, which is where we have a cross section cut perpendicular to the y-axis. The cross sections are going to be squares, and the base is a circle that's created by x squared plus y squared equals 9. So we're going to need to know about this square, and we need to calculate the length of the side of the square. Well, we can do that by looking at the right side and the left side of the circle. So we're going to need to take the circle equation, and since we're working perpendicular to the y-axis, then we want to solve for x. So x squared would equal 9 minus y squared. We'll do the square root of each side. We'll get plus or minus the square root of 9 minus y squared. So if we think about it, the right part of that square that I've drawn would be the positive root, 9 minus y squared, and the left side would be the negative root of 9 minus y squared. And so the length of a side of the square, no matter where that is, would be the right side, square root of 9 minus y squared, minus the left side. So minus negative square root of 9 minus y squared. And so if we combine those, we would have 2 square roots of 9 minus y squared. All right, so now we need to do the area of this square, no matter where it's drawn in the shape. So the area of the square is going to equal the side, so 2 times the square root of 9 minus y squared, times itself, 2 times the square root of 9 minus y squared. And some really nice things happen. We get 4, and your square roots multiply together and go away. So you have 4 times 9 minus y squared, and you could even simplify that to 36 minus 4y squared. So now we're going to calculate the volume of the solid by integrating. Now you're integrating along the y-axis this time. So we're going to want to go from negative 3 to positive 3 along the y-axis, from negative 3 to positive 3. And we're integrating the area, 36 minus 4y squared dy. Now you could notice, in fact, I'm going to do this, that we have a symmetrical graph in that circle. So I could actually just do 2 times the integral from 0 to 3 of 36 minus 4y squared dy. And that would be a lot easier to evaluate. All right, so this is going to be volume equals 2. Now we'll do the integration. I'm going to switch colors here. So our integration volume would equal 2 times 36y minus 4y to the third over 3. And this is evaluated on 0 to 3. And after substituting in, you would get 2 times 72, and your volume ends up being 144. And that's the last of the cross-section examples. Good luck.